How does alternating current go through a capacitor? Let's imagine a capacitor, and alternating current is passing through it. Many people think it works like this. It jumps across. No, guys, that's incorrect. The current does not jump across the capacitor for alternating current, but it still flows through it. To understand this, it's very simple to imagine a hydraulic system. Let's imagine two systems in parallel. A hydraulic system, two pipes with flanges between them. A flexible, elastic kind of membrane, and two wires and two plates, a capacitor. If we supply a constant water flow to our pipes, and fill the pipes with water while applying pressure from one side, what will happen? The membrane will stretch, and on the other side, the water will push a little, bringing everything into balance. The same is true with electric current. If we connect a battery, which provides direct current, to our capacitor, charge accumulation will occur, the charging current will flow through both wires, and a surge of current will be recorded no matter where you connect the ammeter, and then everything will come to equilibrium. The capacitor is charged, and everything is stable. But as soon as we apply an alternating water flow to our pipe, the water is filled in the pipes from both sides, and we start to pump water from one side while draining it from the other. And so, 50 times a second, we start to pump back and forth alternately from different sides. Our membrane will start to bend back and forth, and the flow will seem to move back and forth, back and forth. Electrons move in a similar way in the wires. Electrons do not rush around wildly. They move a short distance when alternating current is present. Only the electromagnetic field moves quickly along the wires. So, if we apply alternating current to the capacitor, it will be the same as in pipes with water. Look, the charges will first rush in from one side. I polarize the dielectric so that it repels charges from the other side. This results in current flowing in one direction. Then the polarity changes sharply, charges rush in from the other side, polarizing the dielectric in the opposite direction, repelling those charges from the left side, and this happens 50 times a second. At this point, alternating current flows through the capacitor, just like the alternating flow of water through this membrane with pipes. That is, water does not pass through the membrane, and current does not pass through the dielectric. But it is precisely the alternating current that is transmitted through its oscillations. Just as the alternating flow moves through a hydraulic system, so does the alternating current through an electrical system with a capacitor. This is what happens: oscillations and fluctuations. The role of the flexible membrane is performed by the dielectric, which gets polarized, that's all.